So the next part is the crank, and I'll zoom in on that a bit so hopefully you can see it a bit clearer. So ultimately we're going to end up with this, but we're going to start off with a rectangular piece of, it says cold rolled steel, so I've got some mild steel plate which I'm going to make myself. So yeah, we're going to start off with a rectangular, we still need to start with a rectangular bit of steel which is 1.7 inches by 1.6 inches. So it needs to be 1/4 inch thick. I didn't have any 1/4 inch thick steel plate, so the closest thing I had was this. So this is a bit of rough mild steel plate, which is 12mm. So I rough cut out a section oversize, squared it up, which is this piece here, squared it up on the Sherline, and then put it in the Warco lathe to turn it down to thickness because it only needs to be 1/4 inch. This went in the forge all quite nicely. So basically, you know, the reason for doing this is that whilst I could have done it on the Sherline, it would take ages on the Sherline to do it because the lathe, although my lathe is only small, it's a hell of a lot more powerful than the Sherline mill is. So I can take bigger cuts even on steel on the lathe. So it didn't take me too long to get that down to thickness. So now I've blued this up. Now I need to mark that off, and then we'll stick it on the Sherline and get it down to the right rectangle size. And then basically we have to drill 3 holes in it and tap 2 of them. This larger hole here in the middle, that is a 1/4 inch drilled and reamed, and that is the part which slides over the shaft. And then there is a small hole which is 0.35 inch away from that, which is tapped, and that's where the conrod will attach to that with one of these screw pivots. And then there's a very small hole which is drilled in from the side and tapped 440, which is for the set screw, which will hold the crank onto the shaft. Now I'm going to do all this drilling and tapping while it's still a rectangle, and then we have to, the final operation will be to put these angles on the side and round off the ends. So that's what we've got to do with the crank. So let's get over to the Sherline. Okay, so we're set up on the Sherline. Now we've got quite a bit to take off on this face and on this face. Unfortunately, this is where the limitations of a small modelling, tiny little modelling mill like the Sherline do come into its own. Now it's fine with aluminium and brass, but with steel, yes, you can machine steel with it. It will cut, no problem, but you only can take very small cuts at a time because it is a very low-powered bit of kit. So, you know, it does take time. It produces a nice finish, but it does take time. So I'll get going on this so you can have a quick look at this, but I'm not going to show you all of it because it is going to take me a while to do both of these faces. But let's close in on that, and then I'll... Okay, so we got our very high-tech, very flash doorknob, which has been turned into a cutting fluid receptacle. Works really well actually. And put some glue on there. Get this going. We only need we're looking at about 800-900 RPM for steel using this size cutter. Okay, well I'm going to keep going with this and I'll bring you back when we're down to size. Okay, so some significant amount of time later, the little block is now to dimensions, and I've marked on there exactly, I don't know, well that's going to, you'll see that on the camera, exactly where our 2 holes are supposed to be. One for the pivot and one for the where the conrod attached. So I'm going to spot drill those on the Sherline now. I'm going to have a go at drilling on the Sherline. I'm not sure whether it's man enough for it, but we'll give it a go. Well, using my calibrated eyeball, I have the spot drill lined up on the first hole, which is the pivot hole. And we're going to spot that. There's a 4mm spot drill in there, so we'll close in a bit for you. And then I'll move it without moving the x-axis. I'll move the y-axis across and spot the other hole. Now we can increase the speed because we're drilling, not milling. So that's our pivot hole spotted. And we'll just wind it across to... Right, there we go. I'll just line that up accurately, so get my head in there. Okay, so now we'll spot the threaded, what will be the threaded hole for the conrod attachment. Right, now I'm going to swap out the spot drill for the 832 tapping drill. Now we've got the number 29, which is the 832 tapping drill in there. You can see how well this does. Seems to be handling that okay. Right, so that's the hole tapped for the 832 thread, which will be on the pivot screw for the conrod. Now I'll come back to the center hole and I'll probably pilot drill it with this and then put the 6mm in, which will then be reamed out for quarter. Okay, very last operation. The hole has been drilled out to, slightly under a quarter, and I've got the reamer in there now, so I'm just going to ream it, and that will be the drilling on this face done, and then I've got to put the hole through for the set screw that holds it onto the shaft. So let's get the reaming done. Slow this right down. Go in nice and slowly with this and it should be fine. There we go. So that's our spindle hole all done. Okay, so I've got a 3mm spot drill in there now. I'm going to make a slight change to the plan here because I haven't got any grub screws in 440 UNC, but I do have some 6BA grub screws. So I'm going to drill and tap that 6BA rather than 440. But for the spot drill, we'll just use the 3mm, which is the smallest one I've got. So I've got it lined up. Ooh, way too slow. That's that done. Yeah, nicely spotted. Now we'll swap that out for the 6BA tapping drill, which I think is 2.3mm. Well, it does seem to be going through that all right, so we'll come back when I'm finished. Okay, so the next operation on this piece is to cut the shape out so that we end up with this shape here. Close in on that a little bit so you can see it. Yeah, so what we want is we want this trapezium, I think you'd call it. I've marked the lines on here, so we'll chop most of that off using the band tool, and then we'll go over to the shear line to smooth off those sides.